Good morning, learners. I hope you are doing well. Today I didn't bring any special lesson, just came to share with you the power of this application, which is called the Milab. Milab is just a set of experiments in a simulation which you can use to model a real experiment in physics or in chemistry. This application was developed by some guys at Nzuni in collaboration with the Ministry of Education and some teachers from selected schools. I found this application very helpful, especially if you are learning at a school where there is no physical laboratory, or you are home scholar, or you study at home on your own, or you go to a part-time school, online school without a physical laboratory. I suggest you can get this application. Just check on the Google Play Store, it may be there, or App Store. Any app store you can check. Just search for Milab app. It's very useful and helpful application. Personally, I found this very useful as well. For example, let me show you something. This is application for simulating Boyle's law. What does Boyle's law says? Yeah, Boyle's law is just one of the gas laws. It states that the volume of a fixed mass of gas is inversely proportional to pressure at constant temperature. Yeah, I think that's what Boyle's law says. Yeah, so we are saying that Boyle's law, this experiment can be used to model Boyle's law. It says that, what does it say again? It says the volume of a fixed mass of gas, yeah? Of gas is inversely proportional to pressure. Right, it's one of the gas laws, I think. So we're saying you can model this law. What the law is saying is that when in a closed system, okay, a gas which is confined in a system, let's say in a syringe or pump or any other gas system, it says that if the volume of the gas is decreased, pressure is going to increase. All right, that's what you mean by inverse. Inverse relationship is one in which when one quantity is decreased, another quantity increases. So an example is that. So where if you confine a gas, let's say you have a cylinder in which a gas is confined, and you apply a force on this piston, so you have gas particles here. If you apply a force down, what's going to happen is the volume is going to decrease. So the volume will decrease, so this volume here will decrease. Okay, so the particles in it are going to be confined at high pressure. So they are going to be colliding with themselves, and also colliding with the walls of the container. So pressure increases because the volume, this volume here, decreases. All right, so you can model this. You can model this equation, this experiment, using this application. Okay, so we have something like a pump here. You have a pump. So we have something like a pump here, and then you have this cylinder here. So this is a pump, and this one is a cylinder. Right cylinder containing air. Okay, and this is something like a liquid. Okay, which when a force is applied down here, this liquid is going to rise up. The effect of the liquid rising up, is that it's going to reduce the space. So this space here contains air particles. Okay, so when a force is applied, so this is a force being applied downwards. Okay, it's going to cause the liquid to rise, up. So as the liquid is rising up, it's going to occupy the space which was occupied by air. So the air particles, as a result, are going to be confined to a very small volume. All right, so because volume is decreasing, pressure is going to increase. All right, let's see how this works. So look, so as this is pushing up and down, the pressure is increasing. The volume is decreasing. The volume in the tube, watch, the volume in the tube decreases until you reach the maximum pressure of 250 kilopascals. All right, so that's what we are saying. I would suggest that you get this application and appreciate the laws that you are learning in theory, because you may not have a physical lab where this can be demonstrated practically. All right, I like this seriously. Another experiment you can also find under the same is to do with the oscillations. Remember, an oscillation is simply a to and fro movement of a body. All right, so let's say we set up a pendulum as an example. Let's say we have a pendulum. Pendulum is simply set up like this. Let's say we have a pendulum. All right, a pendulum is just a string to which a mass, which is called a bob, is attached. So numerous experiments have shown that the length of this string has an effect on the number of oscillations this bob can make. Okay, So let's say this is 30 centimeters. Okay, and if we, upon increasing the what, okay, upon displacing this to some position there, this will be this, the mass will be seen to oscillate from point A, B to C. Right, so what are we saying? We are going to see that if you change the length of the string, make it a bit longer, and also repeat the experiment, you find that when the length is increased, the mass will be oscillating slowly. In other words, its frequency is going to decrease. Right, remember frequency is the number of oscillations the bulb makes per second. So it will be slower here. In other words, the number is going to decrease, the frequency decreases, but when it is shorter, it is going to move faster, making a lot of oscillations in the same time. Alright, so how can you use the application to model that? So look at this. Suppose here we have a shorter string. So when you displace this and let it oscillate, you see that it is making more oscillations per given time. Actually, you can model this at the time in seconds. All right. Okay. But if you let's say you increase the length of the string, let's just say maybe you increase it a little bit to, let's say 30, and you displace it, you see the number of oscillations seems to decrease this time around. You can actually see that the oscillations have decreased. All right, you can see that it only goes a little like that. Okay, but if we get this back, let's say increase the length a bit longer and displace it again, you see the number of oscillations is decreasing. In other words, it's oscillating slowly in the same amount of time. If we make it a bit even much longer and displace it, you do see that it is going to be even much slower. All right, so you see that, you can see this is very important. So why not get it and have it on your phone so that you can model the experiments that you learn in school. Yeah, similarly, so there are many, there's Hooke's law here, there's electricity, there's this is moment of forces. Let's see this one, moment of forces. Moment of forces is an experiment you can do to show a system in equilibrium, or to verify what is called the law of moments. The law of moments says if you have a setup, suppose we have a setup, all right, you have a setup like this, you have a setup like this one, you have a setup like this one. Let's say you have a setup like this. You have a ruler, for example, which you have set up like this, and you pivoted it somewhere there. If you apply a force here at a distance, say d1, and another force F, let's call this F1, this is F2, and call this D1. The law of moment, D2. What the law of moment says is that when you multiply this distance by this force, this should be equal to this force times this distance. That is only when the system is balanced, is in equilibrium, meaning F1 multiply D1 is going to be equal to F2 multiplied by D2. All right, so let us see how the setup can be used to achieve that. Yeah. I hope it's okay. Yeah, so here we have different masses. Let's see if we can pick some masses. Let's say we get this one. I'm not sure how much this is. So maybe we can move it to somewhere here. Yeah. Oh wow. Look at what we have. I've dropped it. Okay, let's have it somewhere here. Or maybe better still somewhere there. Where am I having problems to hang it? Hey God, where is it now? Okay, anyway, let's get this one. Yeah. Okay. So the question is, how much mass do we need in order to balance this? So you try to put mass there, and you see it's balanced. So let's just check if the law is obeyed. So if you look at this mass is I'm having problems to see how much this is. So small. This, let's say this is okay, it appears it's 300 grams. So 300 grams, and is placed on is placed on a distance of this seems to be 55. Not 55. Let's just see. Yeah, this center is 50. Okay, I see. So this is the center of the ruler. It's at 50, but from where the ruler is to, where the ruler is pivoted to where the mass, the 300 mass is placed, it's just 55, I think. So 55 multiplied by 300. Yeah, so you can check that from calculator. We have 55 mazochitika apa guys, 55 multiplied by 300. So you have 55 multiplied by 300. Let's see. Not 55, it's just 5. Oh god. 5 times 300. Yeah, it's 5 actually. So 5 multiplied by 300. It's coming to 1,500. All right. Okay, that's the what? It's coming to 300. 300. Okay, you do the same. This side, take this distance multiplied by this. It should be the same. This is not 55, it's just 5. So 1,500. Here, this appears to be, this is 2, I think. 200. Yeah. So how much distance is this? Yeah, so just check this distance here, and then you multiply by this one. It should also be the same as the one we found the other side, 1,500. That means the system is balanced. I'm just showing you what the application can do. All right, so let me stop here, get the application and see. Oh, maybe we can look at another one, the chemistry one. Yeah, let's go to a chemistry one. So you see there are many. This is for titration. Yeah, you have titration here. Yeah, there's this determination of titration, determination of pH. This is observing endothermic and exothermic reaction, and the others. All right, it shows that my storage is full.